Welcome back, students. Today we would be starting off with question number 12. It says that if A is a square matrix such that A squared is equal to A, we are expected to find the value of 7A negative I positive A raised to the power 3. Now, we are going to be using this formula, which is very popular in algebra. A positive B raised to the power 3 is equal to A cubed plus 3A squared B plus 3AB squared plus B cubed. Now, you all know this cubic formula. Now, just for those people who are new to this, I'm just going to show you a check here. If I were to take A as 1 and B as 1 and raise to the power 3 and substitute the value of 1, now clearly we would get an equation of this form. Expanding and simplifying the right hand side, we would get 1, positive 3, positive 3, positive 1, which is going to be equal to 8. On the left side, it's going to be 2 raised to the power 3. Of course, that's going to be 8. So left-hand side is equal to right-hand side. So this is a very good formula that you all should know. Now, having known this formula, of course, you don't need to do all these things. I have done this just to show you that the formula is absolutely right. So the lower end is actually a check. Now, having obtained this formula, we are going to be using that formula in this question. So, rewrite 7A, open the parenthesis and expand I positive A raised to the power 3, which is going to be I cubed positive 3 times I squared A positive 3 times I times A squared positive A cubed. This can be rewritten as 7 times A negative, open the parenthesis, that's going to be negative I cubed, negative 3 times I squared A, negative 3 times I times A squared, negative A cubed. The question states that A squared is equal to A. Okay, so given that A squared is equal to A, hence what happens? We now have 7A negative I cubed negative 3 times I squared A negative 3 times I times. Now A squared is A, so just substitute A there. A cubed can be rewritten as A squared times A. Now students, from here on it is important that you know certain outputs. Now when I say outputs, you got to know that I squared will always give you I. In fact, I raised to the power 3 will always give you I. In other words, I raised to the power any n will always lead you to I. Have that in mind. Now, having established this result, we can rewrite this equation as 7 times A negative I negative 3 times I times A negative 3 times I times A. Of course, A squared is given to be as A, so that's going to be A multiplied with A. Now, you have to understand another important result. Now, whenever you multiply a matrix with the identity matrix, the outcome will always be A. In other words, the outcome will always be the matrix that you are multiplying with the identity matrix. Now, having known this result that I times A is equal to A, in fact, I times any matrix for that matter will always give you that any matrix, whatever matrix you're using. So let that be a concrete output that you remember. So having known that result, we can rewrite this as 7 times a negative I negative. As I told you, I times a is going to be a. So this is going to be a. This is going to be a followed by a squared. Now this can be rewritten by adding negative 3a with 3a. So that would be 7a. I'm placing negative 6a with 7a followed by negative I. Of course, a squared is going to be a. Now this can be rewritten as 7a with negative 6a would give me a, negative I, negative a. Clearly, positive a and negative a can be cancelled, giving me negative I. So this is the answer to the given question.